Welcome to our session on semiconductor chip shortage. I'm Syed Alam. I lead the semiconductor practice for Accenture. I've been with Accenture for 15 years. Before that, I worked in the industry at Motorola Semiconductor and Freescale Semiconductor. And we have a very interesting topic on chip shortage and the impact on the overall industry. And I'm joined by our leading industry analyst, Patrick Moorhead. Pat, what do you want to?
Yeah, it's great to be here, Sid. Thanks for having me here. It's certainly one of the biggest topics in semiconductors that we're talking about. So there's a whole lot to talk about. A little bit of background. So I'm founder, CEO, chief analyst at More Insights and Strategy. We're a boutique analyst firm. We work with a lot of semiconductor makers and also people who buy semiconductors. So the OEMs and the ODMs and even some contract manufacturers. Before that, I spent 11 years as a corporate vice president at AMD, advanced micro devices, product management, product marketing, corporate strategy, and then I spent 10 years in systems back at the old compact computer, and back when AT&T was doing systems. But it's been a lot of fun, and Syed, what I'm super excited about right now is the fact that semiconductors are eating the world. And I know software was eating the world, but I always said semiconductors can't run on air.
Yes.
But semiconductors are strategic now.
Yes, very strategic. And when you were doing the introductions, I thought when I mentioned Motorola Semiconductor, I aged myself. Then you mentioned compact computers, and I don't feel that bad.
Exactly.
Yes, you're right. Semiconductors right now are everywhere. More and more products, more and more industries are using chips in many more devices. The things that you would think will not use chips are using many more chips now, which is putting pressure on the supply situation. And that's why we are in a capacity constrained situation. And there's a shortage because there is so much demand coming through all of these different industries.
Yeah, it's crazy. The demand is off the charts, and I guess it's a good news, bad news is that semiconductors are strategic, but only if you can get them.
Yes.
And the great thing about, what I'm most excited to talk about is not just how we got here and the severity of the situation, but what are some strategies that chip makers and OEMs can put in place. And we can pong this back and forth, but unprecedented demand was the number one reason that we're here. I mean, PCs, right? We had a 10-year all-time high. I think it was in the third quarter. Yes. Biggest growth in PCs. Now, what exasperated that a lot was obviously COVID, right? Because we had people working at the house, working at work, who then suddenly had to go in their house. You can't take your desktop with an RJ45 and just move it and it's going to work perfectly fine. That's not going to work. So what we saw too was a heavy emphasis on notebooks.
Yes.
So desktops were 40% of the market, but that ended up going to 25% of the market. So even things like PMICs and USB controllers that weren't the same between desktops and notebooks were hit. Then you had Chromebooks that hit for the same reason. Okay, entertainment, we couldn't go outside. Gaming consoles were off the charts. And TVs, big screen TVs, saw their biggest growth in years, upwards of 30%. Then you had the stimulus checks that started coming in, and it's like, hey, guess what? We can buy cars now, right? Yeah. But at the beginning of COVID, the auto manufacturers pulled back on their forecast, which then got them into this really challenging situation. And the EU and the US government intervened, right, and asked all the foundries that said, hey, we need to make sure our auto workers are still at work.
Yes.
We would like you to prioritize the automakers.
Yes.
And you prioritize the automakers, and they had to dial back PCs and Chromebooks. Yes. So it just got us into this super vicious cycle.
Yes, exactly. And automotive industry had a very interesting scenario where they actually went from negative 30% demand to positive 15% demand within 6 months. So a 45% swing within 6 months. And once you give up that capacity, that capacity was immediately taken by the chips for webcam, PCs, large format TVs, and the lead time for these products are so large. When the demand came back, they couldn't get back in those capacity. So that resulted in this prolonged situation for shortage. And one of the other thing which we hear a lot about, advanced chips, leading technology. Most of the shortage is on the older technology.
Right.
Because even before COVID, there was, relatively speaking, underinvestment in the older technology. And when these demand came in for automotive or for simple stuff like PMICs, microcontrollers, display drivers, those needed older technology chips, and those chips are not available. So that also added to this thing. And now the capacity is being added, fabs being built, equipment being ordered, and engineering runs happening, qualification. It's a 12 to 15-month cycle. So that's why this just inherent manufacturing lead time plus the lead time to add the capacity just prolong this whole cycle of shortage.
Yeah, I forgot about the peripherals until you brought this up, and I'm remembering how hard it was to even buy a webcam.
Oh, yeah.
And inside of that webcam is not just webcam technology. There are PMICs inside of that. There are USB controllers inside of those. And I talked to one of the largest PC manufacturers, and they told me, I have 30-cent USB controllers holding up hundreds and millions of dollars in order, and those USB controllers were made on 5 generations ago technology that literally they had nowhere to go, right? Yes. I think they were probably 10-inch wafers, right? Probably 28 nanometer, something like that, which, that stuff works in wireless, but not in other products.
Yes. Yeah, and I think that's the irony you saw, especially in automotive also. Literally, a $2 chip or a $3 chip is, holding the shipment or a sale of a $30,000 vehicle. And I think there is a lot of lessons being learned by the automotive industry and OEMs from this. One of the things that we talk about is using the just-in-time selectively. I think the industry over-optimized on the supply chain, having on the number of turns and having a certain level of inventory. And it makes sense for very expensive component, for example, engine, if it costs $10,000, for example. Okay, you want to maintain a certain inventory levels for that. But 30-cent PMIC,
right?
You can have millions of those, and it's not like milk is going to expire.
Exactly.
It has a very long shelf life.
So did Accenture track the severity? I mean, how bad is it right now?
I think right now what we are seeing is the capacities that we talked about earlier is coming online, and we are seeing, depending upon the technology and the type of the products, things will start to ease in the third quarter or fourth quarter of this year. And then all of these things have to come together also because the advanced chips are available. You couple it with the complete chipset from the older nodes technology and get it shipped also. So, and the other thing that actually we should also talk about is just not the chip shortage that contributed to this. Logistics also. Our research indicates that during pandemic, because of the less number of flights and most of the semiconductor uses air freight, the air cargo capacity went down by 20%. So one, you cannot get hold on the chips. Once you find the chips, you cannot move them around because of the lack of the air freight capacity also. So that also contributed quite a bit to the situation. And then talk about the perfect storm. There was a fire in a substrate factory.
Oh, interesting.
So it just all came together in a very, bad way at the same time.
Well, the irony here is that what is typically at the shortest supply, which is the leading edge, leading edge is an issue for GPUs, right?
Yes.
And which is really exacerbated by the increase in gaming plus crypto.
Yes.
Right? But getting a high-performance CPU which is typically the hardest thing to do, is no longer that problem.
Yeah. Actually, foundries have been investing in the leading nodes because that's where the wafers are expensive. Wafers, you can get $16,000, $20,000 per wafer. So they have been investing in this. And then foundries are also making sure they have the large customers like Apple, Qualcomm, NVIDIA, AMD, who are typically very large buyers of latest technology. They have the capacities for them also. So there was a lot of focus on, for multiple reasons, on building the capacity for leading nodes. And now we ran into the situation that foundry's customer who bought leading nodes, they cannot ship the leading node products because it needs a 30-cent PMIC to go with it also for the whole complete chipset solution. So now we are seeing foundries and other manufacturers also adding the older node capacity also to just make sure that the customer have the complete solution.
Is there any way, was there any way for these folks short term to just add money into the system to be able to accelerate anything? Let's say, I was going to try to keep vendor names out of this, but a Texas Instruments seems to be showing up on the radar of a manufacturer that just can't add capacity regardless, and people are unable to get these lagging edge, either analog type of devices.
Yeah, there is no short-term solution or a quick fix for this. Just the inherent nature of the business. One, 13 to 18 weeks of lead time of just the manufacturing, even if you have the capacity. And then the lead time to order the equipment, the qualification time, yield ramp up, and if you're adding the clean room, the build out of the clean room, all of these add up to a significant lead time. And the industry has been actually always been very conservative in adding the capex because it's such a huge drain on financial resources. And so, they add the capacity when they are pretty sure about the demand coming in, and that's why there was not a lot of flex capacity available when this thing hit.
Right, and the one thing that people also forget is that I think PCs are a great example that put a lot of strain on the system. If you make one mistake in supply chain in PCs, your profit's done, right? Yes. You're already looking at a single-digit profit business of the hardware itself, and then people are making money, with the exception of Apple. Yes. People are making money on the services and the support that go around them, and that conservatism, which I totally understand, having run a business like that before, is what led to this. And they were even doubling down on their logistics to pull it in on air shipping for something like even like a desktop, which you never do because you always put it on a ship. Can take all the profit out of that entire desktop.
Yes, there is increased focus on optimizing the supply chain, and that's where you see the semiconductor companies and the OEMs have come up with a supply chain model where they picked up their sourcing strategy, whether they're going to do a dual source, single source, and they're trying to balance the availability of supply versus the cost. So in theoretically speaking, you can put all your volume with one supplier, you get the volume discount. But then you have a risk of, if there is a capacity or a yield issue, you're out of luck there. But if you try to spread it out, then you don't have the volume discount benefit, but you have a multiple resources. And
yeah, it's interesting. That's the AWS logic to not do multi-cloud, which is give us all your business so you can get the best price and the best terms. But I really believe that the calculus has changed. Things that made no sense before, and I know we're kind of getting into maybe part of the solutions here, but especially in the embedded market, nobody wants to change the design, right? Because it's typically fire and forget, and that's why a lot of these manufacturers, they have tens of thousands of SKUs that never change, right? Because their customers don't want to change, maybe a piece of electronics in that light up there. They don't want to redo the design because you might be talking hundreds of thousands, if not millions. But now the calculus has changed that said, we didn't want to turn this 10 years later or even 5 years later, but in order to get access to more leading edge semiconductors, this might be a good idea, even though it costs us R&D, and maybe it even costs a little bit more on the BOM.
Yes, there is actually increased focus on optimizing the chips or the number of chips or the kind of chips that you're using in your products also. In addition to what we talked about, the supply chain strategy also. If you have, let's suppose, 10 different kind of product lines or 10 different divisions designing the products, sometimes we have seen in large organization, each BU has their own engineering organization, they're designing the product. Let's just take the PMIC example with a certain kind of PMIC. And the next thing you know, you have 10 products with 12 different PMICs. And so now there is a realization is how I can streamline this thing, have one PMIC that I can use across many product lines or have enough volume when I talk to the suppliers also. So that's another thing we are seeing increased collaboration within the organization also. In addition to obviously talking with suppliers on the roadmap and things like that also.
It's interesting. I'm wondering long term if that gives the largest semiconductor makers an advantage if in redoing the calculus. Like if you're going from each engineer of each design making their decision on each individual piece of silicon, you're doing larger buys across the entire engineering organization and finding designs that can also scale. Right? And I think we're seeing that in the automotive industry already, where it used to be with autos, it was, okay, here's the auto, here's the model year, we're locking in, we're going to lock in for 5 years, and oh, by the way, it may not share the same components with this car over here from the same manufacturer, where they're realizing, I think Qualcomm is a good example of kind of providing what they're calling the digital chassis, which, good, better, best, all the way from L1 to L5 as an example, where you can lock in to one manufacturer but have the flexibility to use that socket and use that design across multiple, and with potentially a higher likelihood that Qualcomm can actually get that. Now that's balanced, of course, against getting locked into one manufacturer, right? So I love the different kinds of strategies that can be applied to do this, which might say, go big on one and go broader, or have multiple designs to be able to hedge your bets.
Yes, and I think that's the balance most of these companies are trying to strike. I think there's an appreciation for that, achieving that balance now, because some of these OEMs earlier on didn't even understand. They always knew, okay, that's one of the things that we procure, but now they have a much greater appreciation on about the semiconductor supply chain, how is built around handful number of manufacturers, and what are the things to consider. And one of the things that actually we talk about also is we have been actually talking to our clients quite a bit also, is knowing your supply competition, because OEMs, they spend a lot of energy in trying to find out, okay, you and I both are trying to sell to the same customer, but we have handful number of chip manufacturers. We don't understand that you and I are both trying to get the chip made by the same supplier.
Oh, interesting. Okay.
So have a good perspective on, we always have a perspective of we both are trying to sell to the same customer, but have a perspective of where we're going to get this thing built. Everybody's going to go to the same manufacturer. So what kind of a strategy we have in terms of advanced capacity commitment, sourcing strategy, early buy-in, different techniques that we can apply. So there is a lot of appreciation about that also in understanding the supply competition, because there is actually very fierce supply competition right now that OEMs are learning right now. And in addition to this, also companies are now understanding the complexity of the semiconductor supply chain and the layers involved. One of the OEM head of supply chain, I was talking to him, he was saying they had to Google what is a substrate. He said, I used to not deal with this thing. It's like we order chips, we get the chips, it goes to our contract manufacturer, and now we have to figure it out, this foundry, this node, substrate. So they have appreciation for now, and they are trying to learn more and more about this.
Well, automakers are the best example of that, right? So
Yes.
traditionally, automakers, with their electronics, they went directly to a tier one,
Yes.
or they went to distribution
Yes.
for theirs, and they didn't necessarily have a direct relationship with the semiconductor provider. Now, I mean, Global Foundries is the best example.
Yeah.
Global Foundries just cut 5 deals directly with car manufacturers, and if that's not going far up the value chain,
Yes.
I don't know what is. But in the end, the automakers realized that they just didn't have the relationships, they didn't have the pull, and by the way, the tier ones didn't have the pull either.
Yes.
Because typically they were going through industry chip makers
Yes.
in order to get that. So they were a pass through. I think that another good example is kind of that long tail of IoT
Yes.
that buys through distribution as well. The larger players in that market, and whether it's home IoT or industrial IoT, I'm seeing them creating direct relationships with the semiconductor manufacturers. And by the way, the byproduct of all of this is actually pretty good,
Yes.
right? And it's people who didn't ever recognize the value of semiconductors are now valuing that. And I know some of the semiconductor makers are licking their chops, right, to be able to maybe hop over distribution and not necessarily go direct, but to have that direct more strategic relationship with them. And I think with today's technologies versus maybe 25 years ago, you can manage more relationships now. It doesn't have to be feet on the street, which typically semiconductor distribution would provide. And I know the most strategic semiconductor makers that I'm talking to and I'm working with, they're seeing this an opportunity to go in and make their case directly to the customer that they never had before. So this is one of these interesting byproducts of this challenge.
Yes. Actually, you give a very good example of automotive, and just understanding that one, like the automakers would go to tier one, who will go to the chip manufacturer, who will go to the foundry.
Right.
And now automaker is already directly going to the foundry. So they're skipping 2 middle layers here. And so that's, we would have never imagined that this would happen.
Do you ever think this could change the economics of 2 or 3 tier distribution?
The distributors are already, because of other things happening in the automotive industry, the distributors are already under pressure to see what value they are adding to the automotive industry. So they are already thinking through, not just the middleman, but having a value add component or services into this. They're already rethinking that.
So we talked about get closer to the chip makers, get closer to the foundries, and this is the context of the OEM. We talked about a multi-vendor strategy,
Yes.
maybe having 3 different designs or alternatives to just having one, which is kind of the opposite. We talked about holistic platforms, which is double down on a big supplier, right, that has multiple types of sockets, kind of good, better, best, and capabilities. And we even talked about refreshing maybe an older design that you didn't want to touch.
Yes.
It changes the calculus, particularly in the embedded market,
Yes.
where some people want that design to last for 10 years.
Yeah, and then also using the just-in-time selectively. You don't want to be just driving to the metrics for every single component. For some component, it's okay, you have a little bit extra inventory. If the inventory carrying cost of that component is not that high, and the risk on the other side, I don't have a 30-cent chip, I cannot ship a $30,000 car. So using just-in-time selectively also.
We talked about the CHIPS Act yet. I mean, where does the CHIPS Act play into the solving this problem?
I think the CHIPS Act is tied to a much more strategic priority in terms of having incentives for doing more onshore manufacturing.
It is interesting, though, how it's been tied into the supply chain
Yes.
crisis that we have.
Yeah.
Even though it has nothing to do
Yeah,
with the supply chain
it
crisis?
it adds to the, it's just taking, the environment is ripe for this discussion also. So, and then it's just playing this situation, is playing a catalyst role kind of a situation for CHIPS Act.
No, it's a good answer. I mean, it actually has nothing to do, really nothing to do with it, but it gets conflagrated. I do a media interview every week.
Yes.
On it at least, and it is confusing.
Yeah, and I think there are multiple things like this. There is a European CHIPS Act similar to that that's also being floated. There are incentives by different governments. Some of the large companies are investing on their own also. You saw a pretty large capex announcement by TSMC, Samsung, Intel. So there is a lot of appreciation for the money that's needed to overcome these challenges.
Yeah, gosh, I don't want to end on the strategies here because there's just so many. I've seen some OEM customers shift to more flexible silicon, meaning I was going to go with an ASIC, even that's going to be the cheapest, even though it's not the best time to market. But it's going to be the smallest, right, to FPGA,
Yes.
where I can make my FPGA do 5 or 6 things,
Yes.
as opposed to 5 or 6 different ASICs that are out there. So actually moving in the other direction of programmability, and I've seen that too with a CPU versus a GPU. So it in a way, supply chain is driving design changes in some of these platforms, where a great example, I've seen it in smartphone cameras.
Yes.
Where instead of taking the risk on that special ASIC for that camera, let's put an FPGA in there, and first of all, I can use it for 5 different things if I need to. There's a plethora of availability out there. I can get this because there's not a run on FPGAs.
Yeah. Actually, because of this shortage, there has been a renewed debate about should I use ASIC or should I write a special software, a specific software for certain microcontrollers also. So there is that discussion going on right now also, because sometimes you're using ASICs, you have a limited demand, and and you may not have enough demand to have a cloud with the supplier. But if you're using a generic MCU, then you have a better chance of getting that MCU, and then you write the software for it. So there is a lot of OEMs are going through that discussion right now about rewriting the software for MCU versus keep using.
That's interesting. I haven't heard of the MCU ASIC trade-off, but
Yeah.
I can't. Yeah.
I mean, that's the discussion. I mean, we've seen some of our clients are having. Yes.
So maybe we can talk about. I mean, how long does this last?
Yeah, that's a great question. I mean, everyone is. There is no. One of the things that the way I answer this question is this: there is no, okay, on this date everything is going to be. I hate to give the consulting answer, but there are a lot of factors involved in which technology, whether it's display, driver, PMIC, MCUs, depending upon what kind of a chip it is, and then also, frankly speaking, where is your demand at the supplier? There may be capacity, but are you the first in the line for that capacity, or you're the second or the last in the line? So, so I think depending upon that factor, that's why I was saying earlier, it could be from third quarter to.
How much double, triple ordering do you think is going on in the marketplace?
So actually, that's a very good question, because there is 2 schools of thoughts. One is, we were talking about it earlier, when we have a capacity constraint situation, companies don't want to disappoint certain customers, so they go into allocation mode. And then sometimes they say, okay, I'll give all of you 80% of what you ordered. So now what companies have been starting to doing is this: there is some sense that there's double or triple ordering going on. So at least when I get 80% of that, I will still have enough supply. But then when you talk to the companies that are generating the demand, they're saying, oh, no, this is real demand what we are seeing. So I think the answer is somewhere in the middle. the demand is going through the roof because of the factors that we talked in the beginning. Understand this thing. Last year, the industry grew by 20%. The industry actually shipped 1.1 trillion chips, and we still have shortage. So there is continued demand, but how much supply we need to build is being evaluated. And we talked about earlier, industry is generally very conservative in terms of adding the capacity, because there is also real concern. You don't want to be in a situation that we have oversupply in 2024 or onwards. That also is generally not good for the industry.
Yeah, I look at it from the demand standpoint first, and I like to peel the onion. So first of all, the SIA numbers are based on revenue, okay? Yes. And everybody's got confused that, okay, we grew 20% in 21, we're only going to grow 8% in 2022. That's revenue. But
10%, yeah.
What's the biggest part of the revenue pie of semiconductors is memory.
Yes.
And memory prices are going down, right? Yes. Because they're actually okay with. So, but on a parts basis, we're actually going up, okay?
Yeah,
so on a unit basis. So
unit basis, sorry to interrupt. Unit basis, the growth was 13%.
Yeah.
So since you peel the onion, so that when I say 1.1 trillion chips shipped, that was the 13% growth.
Right. So, and I just bring that up because, especially when I do financial shows like CNBC, it's like, hey, chips are only growing at 8%. It looks like demand's going down. It's like, no. It's memory pricing that's going to go down that's going to impact that. But so I like to start with the biggest to the easiest stuff, smartphones, right? And this is perfect for a scenario analysis. So smartphones, PCs, Chromebooks, cars, IoT devices. I think the big factor on PCs is going to be around, you almost have to predict when the virus is going to go away and we're all going to go back to work. I'm expecting, if people do go back to work, this explosion of growth, okay? Let's say you've been away from your office for 2 years, okay, and you had a desktop PC, and your IT got you a Chromebook because they couldn't get you the right PC. You go back into work, and you have what's going to feel like aged equipment, okay? You go into the conference room, right? And one thing we take for granted here is that one device, one block on Zoom or Teams, okay? And what I've noticed, and what I think is the biggest, going to be one of the biggest learnings, is to attract people back in the office to have their block. You're going to have to upgrade every conference room, okay? And you upgrade every conference room out there, that's more devices, okay, that are going to come. You're going back into the office. And security, those people who had desktops, you have to bet, hey, are we going to have another pandemic and send our employees home? If not, you get a desktop, which is typically viewed as more secure because you can't physically steal it, okay? So it's this level of analysis that goes in there. I think the conference room and PCs are going to explode. Not explode, but be 20%, not 10% that we're at. So I think we're going to be in a deficit.
Plus, I think there is also demand's going to come in from some of the newer devices that got very popular in the pandemic, like for example, XR, new devices around XR, metaverse. All of this is going to drive a new set of demand. So that's another thing. Also, personal fitness. We saw on the shows there's like a personal climbing, personal rowing, there's like all of these.
Well, and I even saw these relaxation pods, and if you haven't seen it, you have to go out and look at it. It looks like something from, I don't know, the future, where people are in a spacecraft and they're in these little relaxation pods and they're drinking their Slurpees and they've got the screen in front of them. I think they call that, home health or home fitness, but you're on your back. So I don't know.
I like that kind of fitness.
It's much better. I like the Bentley bicycle myself.
Yes, exactly.
So.
Yeah, so I think that could also be another factor in terms of the chip demand coming in from all of these different factors also.
What's coming in sideways, though? And I think this is probably maybe a good I don't want, this is your show, not mine.
Good.
A good place to end, but any demand-based oddballs or things that you think people should be watching at, the next electronic pet rock that takes off for 2022, something that may not be expected that you didn't expect.
As I was saying earlier, since the XR devices got untethered, and once they have a little bit more battery life, it's going to take on the life of its own. So that's one of the things I'm monitoring in terms of the demand growth.
My out of left field is I'm sticking to my guns on anything that technology in the office and hybrid work. I mean, go in. I mean, you have 10-year-old Cisco equipment sitting in there, and what we really need is state-of-the-art Cisco, Microsoft, Poly equipment that will has multiple cameras on it in the room. It can segment your face.
Yes.
So to the outside world, the people working remote, one person, one face. You get into big discussions about equality, like why would you want to go to work if you're going to have a crappy meeting experience? I mean, you can suck up to your boss or something, or next to you, but I think people are going to demand to come into the office. They want new tech, and I think most people are going to have to. It seems like you can't force information workers, to do anything anymore, especially in North America and Western Europe. So you're going to have to do something to incent them to come in and not have an excuse. That I don't mean that in a bad way. Just a reason to not come into work.
Yeah, I mean, and then right now we have like 4K webcams at home, and then you go back to the office. Your point is like, oh, this may be a 1080p camera sitting there. So that's a good point. That could drive some of the investments in the enterprise workforce also. Yeah.
All right, are we taking questions?
Yeah, sure. Yeah.
What do you look at systemically in the system that could make a big change, that would make it more resilient and agile moving forward? It's not an editorial, it's just an observation.
No, I think insourcing is something. I think the biggest hurdle that this tech industry has to get over when it comes to physical products is what's happening with relations between China and the West, right? And what that does is it's completely changing the calculus. Very similar to we need more fabs, smaller fabs in more places to be able to limit the risk. And I understand that makes costs go up a little bit, but what's the cost of not being able to get the chips that you need? And I think not only will the relations between China and the US drive that, but the fear of the next whatever that's going to happen. I think we're going to have simpler designs. I think simpler things. You talked about just in time, where your just in time metrics are potentially more inventory, simpler designs. But I see this happening already, and ironically, the calculus started shifting when relations with China started to break down before COVID actually happened. People moving manufacturing to Indonesia over time. You see more fabs wanting to be built on either Western European or American soil. And by the way, the Chinese want more fabs on their soil, right? So this doesn't just go one way. And I think whether it's SARS, right, COVID, China relations, the next potential disaster. I've heard climate change kind of thrown around as we got to be looking at this. Taiwan can't get water, okay? They're having a drought, and you don't have water in Taiwan. You need a lot of water to make these semiconductors. So that's again, fractalizing the fab situation, the chip situation?
Yeah. I would say we're looking at it from three different angles, this resiliency. One is the things we can do physically, as Pat talked about, building more fabs, having a geographical distribution of different fabs. That's number one. Number two is in terms of using newer techniques. We talked about design for manufacturing or design for supply chain, where I gave the example of using the similar PMIC across many products, or having sourcing strategy, multi-vendor approach, and those kind of stuff. So that's the second in terms of the capability. And the third thing is this in terms of running the business, having more flexibility. So you should be able to do more scenario planning. Like, okay, if I don't have this supplier or this product, what's the impact on my supply chain? So we are looking at it from these three different angles, like physical thing, building the capability in terms of how you run the business, and the number three is the tools or the processes, for example, the scenario planning. That's how we're building the...
BOM cost is on a per unit part is rapidly going down in the rank order as well.
Yes.
But there's going to be, there's already a big reset that's happening for that very reason.
Any other questions? Yeah, go ahead, Lisa.
Do you guys see any new innovation on, just talking smartphones specifically that you had mentioned, the easy one? Anything past CMOS that's happening more, that's coming up, or anything interesting happening in the space on innovation?
You want to take that?
I mean, I think the biggest, ironically, some of the biggest innovation is on the gallium arsenic side on RF. That's one of the most interesting things that I've seen on the material side. But the design and 3D packaging to me is everything that the industry needs to be looking at now. Smartphones and smaller devices, it's not going to happen first there, but it is going to ultimately get there. You can imagine shaving 9 months off your design. That's very alluring. And then if you think about the new industry of IP, with probably going to be de facto standard interfaces to work in that 3D environment, probably driven by the foundries, that's the most exciting thing that I'm seeing right now. I think the smartphone is really at a crossroads, right? And it reminds me I spent 10 years in the PC market and then another 10 years servicing the PC market. The smartphone market very much reminds me of the PC market, which isn't necessarily a great place to be, right? Where you have full saturation. People are kind of struggling to find the next new use case. I mean, photography has kind of been the thing for how long? Like 7 years? There was a theory that XR type of things would be the next big thing. Apple's probably going down that path, but what most people are saying is that an enclosed headset is optimal for that. That's probably the only other thing, and I think that industry is probably going to go through a major reset in 3 or 4 years, that people won't buy them as quickly, very similar to the PC did. What the smartphone has going for it, though, is it's very personal. You sleep next to it, right? Your most personal things are here, and it goes everywhere. And you know what? You drop the damn thing, right? And it breaks, which, it's funny, the PC industry loved notebooks for that very reason. And then as they started to get more reliable notebooks, and you could throw them on the ground, the PC market had to find something else that they could do. So I didn't fully answer your question, but there's not an incredible amount of swing me around innovation that I'm seeing there on the semiconductor side, other than 3D.
Oh, but helpful, going to gallium and figuring out energy efficiency. I mean, that is helpful to see that's happening, so thank you.
Yeah, and we're ready for a big battery breakthrough, okay? We haven't had a big... how long have we been using lithium ion, right? And how many ways can you optimize that chemistry? I think we saw, Samsung with the Note 4 and the fires and stuff like that took it to a point where, the danger of even changing that basic lithium ion chemistry is a fire hazard.
Okay, I think that was our session. Thank you. And I hope you guys found it useful.
Thanks, everybody.
Thank you.